It's because that webcam is currently inside the laser cutter. So I'll have this light on for a second. Okay, so one of our members, Ian Taylor, has a laser cutter, and he brought it to the hackerspace. So I have been playing around with the laser cutter for the last week, kind of messing with what materials can I use, how do I actually work the laser cutter. I have experience with 3D printing and CNC routing with our router over there. So jumping into the laser cutter is actually like a really, really simple process. So tonight I wanted to kind of walk you through what that workflow looks like and the kind of stuff you can make with it. I first started with just doing index cards. So I created a simple, just my name through CamBam, and played around with index cards, cutting out, doing some engraving. Then I worked onto, actually, you can start passing these around. Then I jumped into 1/4-inch plywood and 1/8-inch acrylic. So I just went to Lowe's, picked up a little bit of these kind of materials, cut it on a bandsaw so that I could actually fit into the machine. And you can do some pretty awesome stuff. So I have my little logo for Hoffman Engineering, kind of engraved and trying out some different settings. If you want to start passing a couple of these around. The size of that machine, I don't actually know. I haven't really measured the upper limits.
I think it's 320 by
320 by 320. It's this by this, if that helps you out. We can measure it afterwards. It can fit some pretty big things in there. And another example is this is an example of a living hinge. This is just cut out of 1/4-inch plywood. It's wood, but it can bend. So it's cut into a particular pattern that gives it some kind of flexibility. That's a lot of fun to play with. So this particular machine, I am connected to it here. Let me start this, minimize this. Yep, give me 1 second. There we go. So you actually connect to the machine. Usually it's connected to this computer right here, directly connected via an Ethernet cable. You remote in using something like VNC Viewer. That's what I'm using. There's an IP address on there that you just open up the VNC Viewer, usually again on this PC, and you remote in. It's running some version of Linux. The controller software is Linux CNC. So if you've ever used our our CNC router, it's the same exact software that is used to control it. So it should be very familiar if you've used that. So this is the machine, or this is the actual connection to the machine that you do all the control to create what this runs on. So this runs off of G-code. And I created the G-code using a program called CamBam. And this just takes in a DXF file. So you would CAD up whatever design you want, or you can use CamBam's built-in tools. It has, you can create simple shapes. You can create circles, and you can even just write text. So for the Hoffman, I just wrote out the text of Hoffman. So once you have the design, then you can create the different kind of G-code. So there's a pocket, and then there's a profile. So the pocket is the engraving portion. Usually, it's the terminology for the CNC router, where usually you mill out a pocket in the material. Now, a profile would actually go and trace the lines, and so you're just kind of doing an outline. So if you're trying to cut out a shape, you would make those from the profile. If you're trying to engrave a pattern, you would use a pocket. There's really only 2 settings you should worry about when you're doing these pockets and profiles. When you actually create the section, I guess there's 3. There's a target depth. So the laser, what it does when it interprets the G-code is it looks for a negative Z value. So usually when you're routing, you would go, the cutter goes down into the material, and that's when it starts to cut. For the laser, whenever it senses a Z value going negative, it turns on the laser. which is why you can use CAM-BAM that's set up for a CNC machine. It just turns the laser on instead of actually plunging down and cutting away material. So I have it set to a target depth of negative 0.02. This is all in millimeters. So a very small Z depth, but that'll actually turn the laser on. Then a little further, there is not velocity mode, there is a region fill style. So normally it doesn't matter too much when you're doing CNC routing. The kind of profile when you're, the default setting when you're doing a pocket is to go along the edge, move in a little bit, and kind of do these concentric cuts away in that shape. Now that turns out to be a really, really bad idea. I don't have the example up here. It's not a good idea for the laser because if you go over the line twice, then that line becomes darker. So what you want to do is instead you want to switch it to these kind of horizontal or vertical hashes. And what that'll do is it'll just move it over, cutting the laser or turning on the laser, move down to the next one, turn on the laser, move down to the next one, turn on the laser. So it'll do it either horizontally or vertically. And that gives a much, much better results. And then finally is the actual kerf of the laser, the diameter of that tool. I played around with a few different settings. 0.5 millimeters turns out to be the best. Usually when you think of a laser, you think that it's a point, but it's not. There's actually some kind of thickness on there because when you're cutting, the laser is not perfectly focused all the way through the material. There's going to be some distance. So half a millimeter turns out to be perfect for this particular machine. So once that's all done, you can create your G-code, which in CAM-BAM you can say generate toolpaths. It'll think for a second. Let me show the toolpaths. And if I zoom in, you can see what I talk about with these horizontal hashes. Is it just going... I can't do it with the trackpad. But you can see that it's just going over, moving down, going over, moving down. So once you have the G-code, you can save it. You send it over to the machine. And you can open it up in Linux CNC. So I have my logo here. Once it loads all of the different bits. When you first start the machine, there's a couple things you have to keep in mind. The laser is water cooled, so you have to make sure there's a pump underneath and a bucket of water that circulates the water around, cooling the laser. That must be on. The other things are there's a fan, so you want the fan on so that it blows the exhaust out and you don't gas yourself. And then the laser itself has, like the machine has a plug. So you just want to make sure that all of that's up and running. Once you do, first thing you do is home the axes. I will rehome. And what that's just doing is making sure that it knows what position it's at, so it doesn't try to like go off the rails or anything. So once that's homed, you can see that it moved back to the home position. At this point, you would go in, you would put your stock, so whatever you want to cut, your wood, your acrylic. Make sure that you know what you're cutting, because if you put something like PVC and try to cut PVC, you're going to create chlorine gas, and that's no good. So do a little Googling before you throw random material in there. Make sure you know what you're actually cutting. Like polycarbonate, you're probably not going to get too good results with polycarbonate. But if it's acrylic, it cuts perfectly. So just make sure you know what it is. Yes?
For materials that are flammable, like foam core, paper, what is there as far as putting out the fire? Sometimes they
Good
have
question.
a blower that blows right on it.
So we don't currently have one of those air assists. So normally there is, like he was saying, a blower at the very tip of the nozzle that blows air on it to help put out flames and that kind of stuff. We currently don't have one of those. Also that's.
I was like testing it, and I guess I put too much power, and it actually started burning. So like the fan exhaust kind of blows it out. So if you look at it and stop it.
Yeah.
What's the material you got?
What?
What were you doing with?
Yeah, I was doing good.
Okay.
Yeah. So when you're cutting
It'd
wood.
be pretty flammable, so maybe we don't do that yet.
Yeah.
When you calibrate, which you should, you should test run your stuff.
Yeah, so our machine has an analog dial. So the laser intensity is not controlled through G-code. There's just a little potentiometer, a little knob that you turn to adjust the power. Yes?
Could you potentially use it to mark leather? Let's say like a branding.
Yeah, leather is also a material that you can put through there. You would want to use Vegetan leather. I don't know if chrome tan leather engraves well. But you can use leather. I've heard that used quite often to do engraving, that kind of stuff. But yeah, so the laser intensity is controlled manually. So what I normally do is when I start the cuts, I'd go there and I'd be sitting there looking at it, just adjusting to make sure it gets the color or the depth that I'm looking for. And then there's a little gauge to show you how much current's actually going through the laser. You don't want to pump more than 20 milliamps. I don't think this machine can actually get up to the level to harm the laser, but just be aware of that. And also be aware where it's set when you do begin. So I have the part loaded, the G-code loaded. I have, if I switch over to the webcam, so I'm just going to be using a little chunk of wood that I cut off. It's the same 1/4-inch plywood that I was testing with. You just place it inside of the machine. I make sure that the potentiometer is at a pretty low level to start off with. And then there's a physical button you have to press to say that the laser is live. So you press it, you make sure everyone knows there's a laser here. Probably don't stare directly into it. There are glasses around that you can use to help mitigate if you're looking through the top. So yeah, so the laser's live. Let's see how this goes. Did I touch something? Of course, the moment that I go to show something, I'm currently attempting to connect to the laser. Come on. Oh, there's always something. I'm still connected. Now, did it spin stop in a good way or a bad way? Yeah. Okay, I'm gonna restart the board. I have not had this happen like this yet. So while this is coming back up, hopefully. If not, then I can just give a demonstration after all of this. I'll be tinkering with it throughout the night. So while this is kind of reconnecting, is there any questions about the laser cutter? Yes?
Do you know of any list of settings that is appropriate for various materials in this particular machine?
So I have assembled a list of settings for my index cards, my wood, and the acrylic. Currently all of that, if you want to see my saga so far with nice pictures of kind of the step-by-step process, you can go on the Google group. I have a Google group set up, or in our Hackerspace Google group, I have my post there with my entire history, which will have the settings for the wood, acrylic, and the index card stuff. Turns out that with what I've been messing with, there's really not much of a difference besides the laser intensity. So the G-code that I'm currently running has been run on all three materials, with me just manually adjusting how powerful the laser is. Obviously, with things like wood, you're going to pump through more power than cutting through acrylic.
I take it from your comments that the power setting is not programmable?
It is not at the moment. So unfortunately, we can't do things like awesome raster engravings of your face or pictures or anything like that. It's kind of limited to however fine you can control the laser, which is why kind of like couple tone engravings or cutting through a material is what this is currently set up to do.
You say that like there's plans to put it on the program.
I think it's possible. I just don't know. So I've only messed with this printer for the last week. I haven't looked too much into what it takes to convert it into being controlled through CNC or through Linux CNC. So I don't know at the moment any plans to make it not manually adjusted. Yes?
Are there any focus settings for the different thickness of materials?
So there currently is not. The laser is focused through the various mirrors that it has to bounce through. I don't know of an easy way to adjust that without realigning all of the mirrors and getting things tweaked. So you do have to remember that when you are cutting, it is a laser and it is focused at a particular point. As you bring the material up, so if you raise it on, say you're engraving wood and you raise it on another piece of wood, the line that the laser makes is going to be wider than if it was just a single piece of wood, very thin. So depending on where you position it in the machine, you may have to adjust for that. Which is why it's always good to do a test cut on something rather than you have some expensive piece of leather and you throw it in there and then you ruin it. So test your G-code, test your stuff. Let me open back up my Hoffman logo. Script files, parts. Okay, so now I'm going to turn the laser back on. Hopefully don't lose connection. I'm going to rehome the axes so that it knows where it's at.
Is the laser firing right now?
It is not. So the laser will only fire when it receives a G-code command to go negative in the Z direction. So at the moment, it thinks it's perfectly at 0, 0, so it's not firing at the moment. Yes?
Could you tie the Z-axis code, the higher the number, the higher the code?
At the moment, no, because we don't have the laser intensity controlled through the command or through the control board.
That might be a way to do it.
That might be a way. Another method is controlling it through spindle speed. That was something that I heard of. So we'll see what's possible, what we can actually, what pins are available for us to connect it to. So the laser's connected. This is connected. Let me switch over to the laser. And let's start running this. So it is currently running with the intensity so low that it's not actually cutting anything or burning anything. So I'm going to slowly raise the power. Can you see it? There we go.
Another question, are those really the appropriate glasses?
I don't know. I don't know if this is the correct one for the wavelength.
There is a piece of tape.
Yeah, there is a
Hopefully the correct way.
correct one for that.
Well, I know that one is supposed to, but it's not.
Yeah, I wouldn't, be standing over it, staring into it for hours at a time. This is a $300 Chinese laser cutter, probably not the best quality, but it gets results. So maybe set up a webcam like this, view it through the webcam. That's an idea. So as you can see now, it's cutting the belt on the logo that I have, and it's just doing multiple passes, cutting things out. I have found in my experience that doing kind of a two-part approach for engraving is the best. So right now I'm doing that pocket, so it's doing the interior of the design. And then once the pocket is complete, then I do another pass with a profile, and what that'll do is it'll clean up the edges. And especially when you're doing text, it really makes a big difference to do the profile after the pockets. For this, the intensity is probably a little too high. Well, so one thing is, if it does actually catch on fire, then what you can do is lower the intensity, and what that'll put out the flame. So if there's no laser on it, it's no longer providing enough energy to do the flame. So I can actually show you what that'll look like. So Fire. No fire. Fire. No fire. I haven't noticed that. I'm sure if you have a huge flame and a lot of really black smoke, then it may occlude it some.
You can see where the exhaust fan is sucking it out pretty quickly.
Yeah, the exhaust is at the very back. There's kind of like an intake manifold.
I wonder if the parking lot is
Probably.
Don't stick your nose in the exhaust.
Exactly. I wouldn't recommend that. It's wood. It has a nice burnt wood smell afterwards. When cutting acrylic, what I noticed is that when it was done, I just left it sitting in the laser cutter with the fan running for a few minutes to make sure that anything bad is exhausted out. With the wood, the wood has a burnt smell when you take it out, and for the next week, like it just takes a while for that smell to really go away. But yeah.
There's like, I saw this trick where you put tape on your wood so it doesn't like bleed.
Yeah, so what you can do is if you're doing a profile and you want a really crisp edge, you can cover it with masking tape and cut through the masking tape through the wood. And then when you're done, because normally when that flame happens, which is going to happen when you're trying to cut through completely through a material, it leaves burnt marks around the edges. And you can, if you're doing it through the tape, then you can just peel off the tape and there's no longer that burnt edge. Another thing you can do, which is what I did with the living hinge passed around, afterwards, I just took some sandpaper, sanded it off, and it has a really crisp look to it. So you can sand it and do that as well. And that's pretty much all there is to it, to doing laser cutting. It was a lot of fun to mess around with. And I'm going to do a write-up with all of the nitty-gritty stuff and throw it on the Google group or on our wiki, or I'll figure out some spot and make sure that there's nice labeling and you can find that information. So I'll do that at some points. But other than, yeah, any more questions? Yes.
So, it almost looks like it's sparking. Is that the laser going through the gas?
That is the actual laser burning away the material.
What you're seeing is the laser light interfering with the smoke. That's the arc appearance.
Okay.
Oh yeah. If you see a line kind of through like that,
Yeah.
the actual spark, like I'm pretty sure that's just the burning.
Like a fire burner.
Speaking of that though, when I did the acrylic sheets that I had, they were just small, like index card size stuff. So I actually put a scrap piece of wood underneath it to support it in the machine. And how this is sparking when it's actually burning through, when you're doing acrylic, you won't actually see the laser. You'll just see the acrylic start to melt. When I did the profile, so when I actually cut out the rectangle, I adjusted the power enough so that I could see a little tiny spark in the wood underneath, and that told me that the laser was actually making it all the way through the acrylic and, could cut it out. Otherwise, it could be kind of hard to tell if you're going all the way through, and you obviously don't want to crank it all the way up if you don't need to. So that was pretty helpful.
Is it within the visible light spectrum, is it?
Don't think so.
Yeah.
I don't actually know what wavelength this particular laser is.
Who wants that will hurt your eyes?
It's infrared. Right.
Yeah,
Right.
I would assume so. So that's why you just don't want to stare at it. Don't open up the cover. Don't open up the cover. There is no kind of safety switch, so you can just open it up while the laser's on. Don't do that. Be smart. And also make sure that everyone around knows that the laser's running, so they don't just go over, open it up, that kind of stuff. Typical safety measures.
Have you tried pumping nitrogen in there while you're cutting? Do you think that might cut down on the sparking and smoke?
Possibly. I haven't tried it. Is that a normal thing for laser cutters to do?
I don't know.
I have no idea. I do know that's the kind of air assist where they are just blowing air where right at the point where the laser hits. That does a lot to cut down on the smoke and that kind of stuff. So, or nitrogen if you want to have a constant source of nitrogen. But I think a little aquarium bubble blower is cheaper than a bunch of things in nitrogen. We can try that though. Any other questions? few more.
Is there any like plans for like a carbon filter for the exhaust, so you didn't have to dump it outside?
Plans for carbon filter? Possible. I don't know. That's something we can discuss. It's probably a good idea to consider that. Throw some HEPA filters on the back. Start filtering out some of this stuff before we just dump it in through the exhaust. That's a good point.
HEPA filter would only help with blocking particles leaving. I'm thinking of something converting into toxic gases.
We can talk about that. We can figure out something. Yes, Brian.
Do you find you need to fasten it anyway so it doesn't rattle and migrate around?
What I did, not for this part, but for some of the other pieces, is I just took some tape and kind of taped down in a couple spots. I haven't noticed it moving considerably without it being supported, without it being taped down, but it probably wouldn't hurt, especially if you're trying to do something that doesn't rest well. There's like a giant hole in the middle with a weird raised section that has some really like cheap clamping stuff that you should never use. Just set it on top of it because it's terribly designed. You'll know it once you look at it. It's bad. So I just have it resting on top, so it's supported like along this edge and along the bottom. If you feel like something could move, just tape it down. As long as the tape doesn't hit the laser, you're probably good. Even if it does, I don't know. Yeah, good question. Last one.
So when you do a through cut, is it just a power setting, or do you do multiple passes like you do down this one?
Tons and tons of passes. That's a good question. With the acrylic, I did just one pass with the laser at about 8 milliamps or so. There's a little dial indicator that will read the milliamps. So I just adjusted it until I saw it cutting through, and that only took one pass. For the wood, it took at least 10 passes. And yeah, it took a while. So 10 passes. The first pass, because it flames so easily at the surface, it was at a pretty low setting, about 4 milliamps. As it got deeper, you can crank up the power for the laser. And because it's down deeper, there's less oxygen blowing at it, and it's less likely to flame up as bad. So I just did multiple passes, just running the same G-code over and over and over again until it cut all the way through. But yeah, so you'll have to experiment if you try out different thicknesses of material, different types, how many passes you would need. But yeah. Cool. So that's laser cutting. And now we have a nice engraved logo.